That is me. So I want to apologize right off. I'm here to talk about reworking. This is a Bitcoin Core specific topic, and I've been working kind of feverishly over the last few weeks to get some code whipped into shape so I could talk more definitively about working things rather than theory. So the presentation itself suffered a little bit for that. So Bitcoin Core has a networking stack that dates back, I think, all the way back to the initial implementation from Satoshi, and or at least it's been patched and kind of hacked on ever since. And it has some pretty serious limitations at the moment. One of the biggest, or I guess I should say two of the biggest that actually got me kind of whipped into shape for this particular topic is there's no throttling, which is one of the most requested features that I see on the network side of things, meaning that it's relatively easy if you get a bunch of nodes connected to you for them to just suck away your bandwidth. There's very little that you can do about it. The configuration is very static, so in actually hacking on the networking code, you find that it's very hard if you want to do something simple, if you want to disconnect a node, if you want to ban a node, if you want to do things on the fly. It's actually much more complicated than you would expect to do things like that. The same with diagnoses and simulations and testing. Because of that kind of static configuration, it becomes hard to do those things. So the other major interesting thing that really got me into looking at the current networking issues is what I call the peer-to-peer latency, which is a terrible name and it doesn't describe at all what I'm trying to say. But what I mean by that is the lag time between the time that you receive a message, process it, do something with it, and are able to respond or do something as a result of it. So again, this is pretty core specific. So Bitcoin Core developers, I think, will recognize some of these things, and I'm sure they could add to the list very easily. But some of the big issues at the moment, number one, select doesn't scale. So for the most part, on most Linux systems or most Unix-based systems, you have a pretty hard or a pretty assumed limit of 1024 file descriptors. So you can pretty much say right off that's the limit of connections that you're going to get. So there are major locking issues, and this is very specific to the Bitcoin code itself. So it becomes very hard to make any changes to the way that connections work, connections are established, the way that proxies work, the way that basically anything regarding sockets and data transmission is just covered with locks, covered with some crazy code paths, and there's some pretty spaghettified code that has emerged over time. So the result of that, and it's something that I'm not sure has been analyzed all that much, but what I consider to be one of the major scaling issues at the moment for the networking side of things is how much is done on the message handling thread in Core. So what that means is, as we receive messages on the network and process them very quickly, there's a lot of thread contention because things like block validation, transaction validation, all those things are happening on our message handling thread. So as more and more starts coming in over the network, we become less and less able to process it. So I haven't seen really many or any proposals, things to address that particular issue, and given the amount of given the current code base and its fragility, I decided to dive in and essentially look at a complete rework of the networking code. So this is one of my primary motivators. I was doing a sync, the initial block download, a few months ago, and this was the before. This is on my MacBook, which is about a year old, I suppose. And one of the things I noticed, one of the trends that emerged very quickly, was this peaks and troughs trend. And I think most people would see that definitely the slower the computer that you're working on, that you're trying to sync with, you would notice that trend even more strongly. And so what's happening there is what I alluded to a minute ago. It's the fact that as blocks are coming in, as data is coming in, we can't process it fast enough because we're doing all this validation, and headers first actually made this a lot worse because as blocks are coming in out of order, you may have 15, 20, 30 blocks queued up that don't actually connect until the right block comes in. So there can be tens of seconds or even minutes that go by before you can request a new block. So that's what we're seeing here. The valleys are where we're currently churning and chugging away, doing our best to validate things, and we're not able to request new blocks coming in. So network traffic just drops, and over the long term, you see this drop to basically zero. So I ran a quick experiment. I added some new threads to do some of that block handling on a new thread, and this is the result that I got. So I want to make it very clear. This is the award that I went ahead and gave myself for the most simplified data here, because this says nothing. This is not at all useful, but it was enough to prove to me that it is at least possible to offset some of this peaks and valley kind of trend. So I've started working in the last few months, and really I've kicked it into high gear over the last few weeks to work on just a complete replacement for essentially the networking stack inside of Bitcoin. So more threads is kind of traditionally what we've done to make Bitcoin Core scale, and anyone who's done networking and kind of on the low level knows that really doesn't, that stops being useful at some point. So I started looking at things that we could do asynchronously instead. So at the moment, pretty much everything in Core on the networking side is done synchronously. We spawn some threads, we spawn some connections, we wait for them to connect, and then we act on that instead. And so as a result of that pattern, the Bitcoin Core logic tends to behave the same way. So we wait for network, wait to establish a connection. Once we have that connection, we start talking to it. We establish, we run the handshake and start asking for blocks. But as you try to scale up on the networking side, it becomes much easier if you have your network say, I'm connected now. What do you want from me? So libevent is a library that is essentially written to handle these kind of issues. It was actually, its usage was just merged into Bitcoin Core for a different RPC server over the last few weeks. So there are a few complaints about adding a new library and depending on third-party code for Bitcoin Core for some of the core logic of it. But I would say that it's a pretty well-established library already. There's a lot of things that it does for us that we do. Like if you look at this list, it's kind of insane that we do all of these things manually in Core at the moment. So it handles socket creation, binding, polling, buffering, watermarks, blah blah blah. But it also handles prioritization, which is really nice and something that is very handwritten in Core. So you can say this node is more important. Give it a higher priority. Let it make sure that I know that it's connected before the others, or make sure that its data is synced before the others. It also uses epoll, KQ, or I'm not familiar with IOCP, but its IOCP is used for Windows where possible, meaning that for most Linux systems, for most OS X and BSD systems, we won't be reliant on select anymore. So that kind of soft or soft-ish limit of 1024 connections that we have at the moment just kind of goes away. We don't have to worry about it anymore. So this is the approach that I've taken. I've tried to add the concept of a singular connection manager for Core that we can query it. It runs an instance. We can ask it for it. It doesn't. You don't say establish a new connection outward. It says, hey, I don't have enough connections. Give me somebody to connect to, And then after a few seconds, it says, okay, I'm connected, what do you want to do? So it kind of reverses it. It looks at things from the network perspective or from the buffer perspective. Because of that, because the direction of thing changes, it also would make it much easier to kind of reverse that logic in the core code as well. To say, somebody asked for a block, what do you want to do about it? Instead of saying somebody asked for a block, I'm gonna stop everything and go find that block and send it to them, which is what we do now. So in writing the manager, it became obvious pretty quickly when you're as I was working on the code to actually establish the rules for how to manage connections. It became clear that a network connection manager itself really doesn't have to know anything about Bitcoin itself. It has to know like two or three things. It has to know how big a header is, what the size, what the message size offset is inside the header, and then as one tiny optimization, it knows a little bit about the version handshake, because the first incoming message is where you establish a lot about the connection information itself. So you can avoid some races by saying, before I'm notified about that I can start sending messages back and forth, do this version handshake, and then continue. So in working on this new manager, one of the things or one of my goals that I set out for initially, and I've stuck to so far, is writing it as a new standalone library. Not that it makes sense to use it that way. I don't imagine this being useful to anybody else or being implemented in other programs, but it does make for much easier testing. You can write a very quick stub application to say, simulate an initial block download. Simulate this scenario without having to deal with all of the other Bitcoin-related things that are going on. You can test, say you just want to test how easily you can connect it to 2,000 nodes, or how easily you could spawn an attack. You can write your own little stub applications. That also means that because nothing is hard-coded and there's nothing global, lots and lots of things become dynamic in Bitcoin Core. So I would love to see the ability to, one of the things that would have been really helpful in my testing was the ability to just kick a node, say, I don't want you connected to me anymore on the fly, and limit somebody's bandwidth on the fly. If you notice somebody's sucking up all your bandwidth, limit them in particular, but leave everybody else kind of unlocked. So the current status is that it's ugly. And my primary intention for coming and speaking here was actually to kind of kick off the idea that it is something that I'm working on. It's going to be, trying to get this merged into Bitcoin Core will be a big, nasty process, I think, because it'll be a whole lot to try to dump in at once. So I would really like to gather some ideas, talk to some people who have, Matt probably being one of them, people who have analyzed network traffic a pretty good bit to understand pitfalls to avoid in the future, to try to not make some of the same mistakes that we made. So I am happy to show, though, in the second most boring graphic, this is something that I ran. The code actually came up 2 days ago, and so this is an initial block download where you can see it downloaded about 1.25 gigs worth of data, and I had set a throttle of 1 meg per second of download limit, and you can see that number was hit pretty much exactly. So at least that part does work. So I do have a plan for trying to get it merged in, but it's going to be ugly. So as far as Daydreaming goes, once we do have a new network manager, I think that it opens up some very interesting possibilities. One, I was talking to Jonas about this last night. I think this is important going forward. Since the network connections would be instanced, or the manager would be instanced, it would become possible to say run 2 different sets of services at once. So say I advertise node network on this side, and on the other side, or on another simultaneous port, I advertise node bloom or any of the other server features that you would want to run. So you don't necessarily have to be static about it. It could also give the ability to, you could start as a pruned node until you acquire all the blocks, at which point you could dynamically say, I'm a full node now. You can grab blocks for me. So lots of interesting things beyond that. I think a Cursus GUI to be able to interact would be very helpful for people that run VBSs. Unix sockets, I have no idea how that would be helpful, but it could be possible. Out-of-process networking would be the same way. I don't imagine how that could possibly be useful, but who knows. So again, my primary intention here is to kind of introduce the idea and hope that I can talk to you about some of the issues that you guys have run into. Anybody who runs nodes with lots of connections or runs a bunch of nodes and have run into networking issues, please find me and talk to me about it. Thank you.
Thank you, Cory.